Hello everyone, welcome to electric power. Now I know we have covered it briefly, but now I want to revisit it again. Do you remember what the equation was? Do you? It is power equals current times voltage. Remember my professor Ivy, which is a true person. He's a real life character. So this is what we're going to be revisiting, the electric side, not work or energy over time, just this for today. Also, let us review Ohm's law, which we have just learned. And this will be V equals IR. Now, let us kind of combine the two. Let us see how we can play around with these equations and see what we can do here. You can see here that there is no resistance. I can find the power using just these two things, but what if I don't have current, and what if I don't have the voltage? How can I figure out how much power there is in my system without one of those things? And now that we have this equation, this very powerful equation, we can play around with it and figure things out. So I can plug this in for V, and also for I can figure out what I is. If I divide R to both sides, I would equal V over R. So using this equation and that equation, I can find new equations. So if I plug in for V, here I will have I times R, which equals the current squared times the resistance. So that is a very good equation. Power equals current squared times resistance. And also, I will have power equals, if I plug in this equation for my I will have V over R times V, which would give me V squared over R. So power is equal to the voltage squared over my resistance. Hopefully this helps. These are new equations that now, do you have to memorize these? No, of course not. You always have that option. However, there's no need. You definitely need to memorize this and this, but from both of these equations, these pop out. So you don't need to memorize them, but they are very, very useful. This is more of a conceptual problem, although I actually will write it out a little bit, but it's the conceptual one. It says, which would be thicker, the filament of a 60-watt light bulb or the filament of a 100-watt light bulb? I think I wrote 120 for you guys, but we'll just use 100 for right now. So which one would be thicker? Let's think of that. Okay, so the thickness of the wire, what does that refer to again? Does it refer to the current? Directly? No. The voltage? Directly? No. So if we remember our equation, and this is one that, although quite important in the grand scheme of things, for this class we don't need to memorize it, but you should at least have an idea as to what it is. Remember, resistance is equal to the resistivity times the length of the wire over the area. So when I talk about width, what does that refer to? Does that refer to the resistivity, the length, or the area? I know you might think width refers to the length, but it does not. The width would refer to the area, because that would be the diameter, which you can find the radius and find the area. Again, so think of how many lanes. So if I have more lanes on a road, would that have more resistance or less? If my wire is bigger, would I have less resistance or more resistance? So if this is bigger, if the width is bigger, this is going to get bigger, which means my resistance goes down. If my resistance goes down, right here, then my power will go up. Do you see that? Moving on to the next question. Here it is. What we are given is the power and the voltage in the outlet. We need to find now the resistance and the current. So I'm trying to figure out what R will be and what I will be. I will be what I want to be. So using power and voltage, which one is the easier one to find out first? Well, if I look at my very powerful equation right here, I can see that I have this, and I'm just trying to find I, so I can solve for I pretty quickly. I, or my current, is just going to be equal to my power over my voltage. So that will be 7.5 watts divided by 120 volts. So my current will then be 0.0625 amps. Let's go to my resistance. It is not as straightforward, but thankfully we have these equations right here, which again we do not have to memorize, but you can write it down and see that it's right there. So I have everything I need. You know, I have resistance, I have current, and I have power. One thing that I would personally want to do in this situation, even though we just found the current, I would rather use our knowns for this equation here, because I know 100% that this is this and this is that. It is quite possible that I may have miscalculated what my current is and therefore have get my next problem incorrect. So let us use the one with the knowns, which is power and voltage. So this equation right here, let me manipulate that, bring the R up here, bring the P down here. So R is equal to V squared over P. My V squared will be 120 volts divided by my power, which is 7.5 watts. If I do that, don't forget to square this. Ooh, I almost forgot to square that. If I do that, my resistance would be 1,920 ohms. So that is R and that is I. Good. On to the next one. Actually, this will be our last one for today. And here is the problem. Now, when I look at this, I only have one known, and I'm trying to find two different things. So I am definitely given the current, which the current is 1.99 amps. But I'm trying to find the resistance and the power. What in the world? How do I do that? Well, assuming we are in America, cue the everything else, then you should know that my voltage automatically will be 120 volts. This is what's coming out of the outlet. So let's use this to figure things out. Again, so I have my current, my voltage. What is easy to figure out right now? That is the power. It comes out pretty easily, not too bad. So I just multiply them. So power is going to equal I times V, which equals 1.99 amps times 120 volts. That will give me 239 watts. Let us solve for the resistance. How am I going to get that? Well, do I have to do one of these? Now I could, because I just found it. However, I always like to use our knowns, which is current and voltage. And look at that, we just happen to have that equation right there. So to be able to find the resistance, I need to manipulate this equation, divide I to both sides. So R equals V over I. So that will equal to 120 volts divided by 1.99 amps. And you know, I can do a little rounding, doesn't matter, but it should be 60.3 ohms. Not bad. So if I give you any equation with, I guess, two knowns regarding voltage, power, current, or resistance, you should be able to use these equations primarily or manipulate them to be able to find the other two unknowns. Good luck. Have a great day.